Here we are asked to evaluate some limits. The special part about these limits is that they are approaching either infinity or negative infinity. What's going to help with limits that approach infinity or negative infinity is what does the graph look like? Because the limit as x approaches infinity or negative infinity, really that's just looking at like the end behavior as x approaches infinity or approaches negative infinity. So if I know what the graph looks like, then my math becomes very simple. If I don't know what the graph looks like, maybe, plugging in infinity and seeing what happens, then that might be more helpful. So let's see here if the graphs help. And if we know some basics about graphing, then it'll be pretty straightforward. So first one here, what I'm dealing with is a quadratic. The quadratic is positive, which means that I have this U shape here, and both ends point up. So as I go to the right, or as I go to positive infinity, then I know that my y value is also going towards positive infinity. So this limit here's value is infinity. Second one here, this is an exponential function because x is in the exponent. Exponential growth, and it's positive, meaning that my graph looks like it has an asymptote here at -8. And is exponential growth, so it's going to look something like this. Do I need to know exact points? Not for this really, because I'm just looking at the end behavior, or as x approaches negative infinity. As long as I know these kind of facts here, I see that the left side, or as I go towards negative infinity and the x value, my y value is heading towards this asymptote, which, as I said earlier, was just -8. So in this one here, really another way that you can think about it is if we're plugging in a value, right? I'm plugging in an extremely big negative number into here. When I have 2 to the power of a really big negative number, it becomes this really, really, really small fraction, and then I subtract 8 from that. So like it gets smaller, and then I subtract 8. So it makes sense that we're kind of heading towards that -8 for this one here. Next one here, this is a rational function. A couple things about a rational function. In general, a parent function might look, this is ugly, might look like this, again, but better, because naturally my asymptotes are at 0 and 0 for a rational function. In this case here, a couple things I need to think about, though, is that my horizontal asymptote on this one, because the degree on the top is greater than the degree on the bottom, I'm actually going to have some sort of slant asymptote. So again, my graph of this one, just because of what I know about rational functions, might have some sort of, vertical, I don't know, let's call it over here, vertical and horizontal asymptote like this. And because it's positive, my graph is going to kind of look like this here. So that's I don't know, I guess that's a big ask to understand that this function looks kind of like this off the top of your head. So if that doesn't work for you, that's fine. Let's just talk about like what's happening here when we plug in infinity, because if I plug in infinity here, it's going to get cubed, which is going to make it big very fast. I'm also going to be plugging in infinity here to x squared, which is still becoming bigger, but it's becoming bigger at a slower rate than this one here. So what that means is that as this number gets bigger, then I know this number is also getting bigger. And as it continues to get bigger, then the y value gets bigger. And so really I should know that this limit approaches infinity, which again, if I look at my graph right here, I see that like as we go to the right, my y value is going up. So again, that's a little bit of a tough one there, but the rational functions, they become a little bit easier if you know the exponent rules. So, sorry, not the exponent rules, the horizontal asymptote rules, in this case, slant asymptote. But you'll see here, so the rest of these look like rational functions. So again, I'm going to have this idea where I have, either a horizontal or slant asymptote and then a vertical asymptote. So we'll kind of see what happens there. But another thing that we should pay attention to is the fact that any rational function, the end behavior always approaches the asymptotes. This one was a slant asymptote, and so again, we approached that slant asymptote, which was going on upwards forever. The next one's going to be a little bit different. So in this one, because the degree on the top is less than the degree on the bottom, that means that my horizontal asymptote is going to be at y equals 0. So no matter where my vertical asymptote is, it's really at -2 here. That's not at -2. Yeah, it is at -2. So in this case here, we're going to have this horizontal asymptote at y equals 0. So when I graph this, again, the idea here is that it's going to look something like this. Again, I'm not making specific points here, but it's what I know about rational functions. And so what I can see here is that my left side, because as I'm going towards -infinity, my y value is approaching 0. So in this one here, another way to think about it is like these values, we're plugging in a negative on the top and the bottom here, and as they approach 0, then we get like this. Sorry, as they approach -infinity, they approach 0 here. So the easiest way, in my opinion, is to look at the graph. A couple more here talking about rational functions, and then we'll wrap it up. So in this one, we have 2 degrees that are the same. Our horizontal asymptote rule then is that it is the leading coefficient over the leading coefficient. So our horizontal asymptote on this one's going to be at +2. And so again, if we have some sort of value here that would make this positive. Oops, sorry. We have some sort of vertical asymptote somewhere, and doesn't really matter though, because the horizontal asymptote, as we approach positive infinity, my y value is still going to be approaching this horizontal asymptote, which is at 2. Last one here, same idea. I have 2 exponents that are the same, so degree on the top is greater than the degree on the bottom. So my horizontal asymptote is at 2/6, or 1/3. So my limit also approaches 1/3. So the idea here, a couple of things to just try. Like if you're working on these problems, plug in infinity. If that makes sense and gives you an answer that you think makes sense, great. The other thing that I recommend is graphing it, right? Know what we need to know about, in this case, quadratics or exponential functions or rational functions, because the graph is often helpful to show us where it's heading. In rational functions specifically, as we approach infinity or negative infinity, we're always approaching those like horizontal asymptotes or slant asymptote. If it's a slant asymptote, it's going to go to infinity or negative infinity, whereas if it's a horizontal asymptote, it's just going to be pointing towards that actual value. So in that case there, we are all good to go when we are approaching infinity.